All right, in this problem, we are looking at a total of 171 children that were randomly split into two groups. One group had 90 of the children, the other group had 81 of the children, for a total of 171 from children. And here we're looking at the number of self-reported criminal offenses by the age of 15, and we want to see if splitting them into the experimental group or the control group. So this was cognitive preschool versus traditional preschool, and we want to see if there's a difference between the experimental and control group. Okay, and so it says in that near the last sentence before the source, it says test the hypothesis that the mean number of self-reported offenses is not the same for each group. Okay, so in this case, our null and our alternative, the alternative is that they are not the same, and the null always has an equal to sign, which means they would be the same. So we would have mu1 is equal to mu2, mu1 not equal to mu2. Alright, so when we rewrite these, we would write the mean of group 1 minus the mean of group 2. That difference is 0, and the alternative is that the mean of group 1 minus the mean of group 2 is not equal to 0. So again, anytime you see a not equal to sign, you have a two-tailed test. So what we observe is the experimental group is 12.62 and the control group is 11.05. So is there a difference? Sure, these two numbers aren't the same, but is the difference between them, is that significant or not? So our test statistic is always what we observed. So in this case, the observed difference minus what's specified in the null hypothesis divided by our standard error. What was the observed difference? That would be the difference that we see. So here we see 12.62 is the mean of the experimental group. The control group had a mean of 11.05. So the difference between those two numbers is 1.57. So that's our observed difference, 1.57. The null hypothesis says that there should be no difference between them. And here now we have to figure out our standard error. So the standard error is s1 squared over n1 plus s2 squared over n2. Okay, so this would be n1, and this would be s1, and this would be s2, and this would be n2. n2 being the number in group 2, s2 being the standard deviation in group 2. So it's just a matter of plugging in these numbers. 14.27 squared over n1, 90, plus 13.66 squared over n2, which is 81. So 14.27 squared over 90, 13.66 squared over 81. I take the square root of that number, and I get 2.1369. Okay. I just leave my numbers in the calculator, and I'm going to do 1.57 divided by that answer, and I get a test statistic of 0.735. Okay, so this is my test statistic, which is my t-score basically that I'm going to be looking up. And so here it shows that I am 0.735 away from the mean, and I'm looking for the area in the tail, but because it's a two-tailed test, I've got to double that area in the tail. So in one of the tails, I would find the area in one of the tails and then double it. Okay, so the degrees of freedom that I have would be n minus 1, which for whichever smaller group I have. So here in this case, the smaller group only had 81 people in it. I subtract 1 and I get 80 degrees of freedom, and I'm trying to see where 0.735 as my test statistic lines up. So in this case, with 80 degrees of freedom, I see the first number that shows up is 1.292, and then the next number is 1.664. So this test statistic, 1.292 corresponds at the top to probability of 10%, and 1.664 corresponds to tail probability of 0.05 at the top of the table, and here I see 0.735 would fit over here, which means whatever this area is, I don't know exactly what it is, but this tail is going to be greater than 10%, which means this tail is also greater than 10%. So the total tail probabilities, which would be my p-value, is going to be greater than 20%. I don't know exactly what it is, but based on my numbers, I do know my p-value is greater than 20%. And so here, because if I use a significance level of 5%, my p-value is greater than alpha. That means I do not reject the null. That means we do not have evidence. That the means are different. That the mean number of self-reported crimes for the experimental group and the mean number for the control group are, we don't have any evidence that the means are different.